All right, so we just finished factoring polynomials, and this lesson is going to be about dividing polynomials. So dividing and factoring really are the same thing. It's just like factoring is like you're unmultiplying, so that's kind of what we're going to be working on here. Now, there are some really crappy ways to do division. For example, you can do long division, which you all already hated as usually as elementary school students. You were not fans of that, so here's just a lovely reminder of what long division looks like. And in algebra, long division looks like this hot mess of an answer. Okay, so if you really want to do this, you can come to tutoring and I'll show you how to do this lovely, beautiful thing. And if not, let's pretend that it doesn't exist because no one needs that kind of negativity in their life. Am I right? All right, so what I want to show you is a quicker way to make this same thing happen. All right, and that's by this thing called synthetic substitution or synthetic division. They both mean the same thing. I don't really know why there are two options, but there you have it. Okay, so let's just go ahead and compare these two examples because these two things are doing the same, figuring out the same goal for us. So in the long division, I'm dividing 3x to the third plus 4x squared plus 0x plus 10 by x minus 2. So notice in the synthetic division that x minus 2 becomes positive 2. It's kind of like, I mean, it's not kind of like, it is. When we go from a factor to a root, how you have to change the sign, that's what's happening there. Notice where the 3, 4, 0, and 10 are coming from. In this top line, I've got 3, 4, 0, and 10. Those are the coefficients. So those are the numbers that get put in the top line here. I do want you to see that this 0x is here. Like normally you wouldn't see 0x written in an equation, in a polynomial, but here we're going to have the 0 because we need to count down x to the third, x squared, x, and then x to the 0. You have to have a placeholder for every exponent. So that's why we have to add the 0 there. So now let's go ahead and look, and let's see some other, similarities. We've got this answer at the top. This is our answer or our quotient, if you remember that division word. Notice that answer is secretly down here in the bottom, all right, 3, 10, and 20. And then the last part that you should see here is this remainder. So I've got this remainder of 50 at the bottom, and then I did not spell that right, remainder. And then I have this remainder 50 in this box at the end. So let me zoom in and show you specifically how this synthetic division works. So, you put the root in the top corner. We've got these coefficients in the very top line. So if we go ahead and notice the pattern in what's happening here. All right, you bring the 3 down, and then we're going to multiply that number by what's in the box at the top. So I brought the 3 down, multiplied by 2, and that gave me this 6 right here. Okay, then I'm going to add 4 plus 6 is 10, and then I'm going to repeat the process. So now I'm going to multiply this 10 by the 2. Notice that gives me this 20. I'm going to add down. That gives me 20 here. Then I'm going to repeat the process. Multiply 20 by 2. That gives me 40. Add straight down. That gives me 50. Now your last number will always be a remainder. So this box at the end is always going to be your remainder. And then the other numbers that are left are going to be your coefficients for your new polynomial. So let me just kind of explain a little bit more what that means. So remember in the very beginning, I had 3x to the third, 4x squared, 0x, and then just 10. When we divide, we're going to be cutting down on one of those degrees. So now instead of starting with x to the third, I'm starting with x squared, x, then just the 20 and the remainder of 50. So this all means that this problem, the answer to this division problem is going to be 3x squared plus 10x plus 20 plus, we have a remainder of 50, and we can't just say like R50 like you used to do in elementary school. We actually need to understand what that means. So this answer means plus 50 out of x minus 2, and that's because that's the factor that we started with. All right, so make sure you have that written down, and let's try an example together. All right, sorry, before we do that example, one more implication that I wanted to remind you of or show you is that this remainder and what you divided are actually an ordered pair on the polynomial. So for instance, it means that this polynomial, 3x to the third plus 4x squared plus 10, contains the point 250. And if you didn't believe me, you could type this polynomial in your calculator. You actually might want to do that real quick and look in the table, and you should see the value 250 as an ordered pair in the table. That's going to be important here in a minute. All right, so this example wants us to determine whether the binomial is a factor. That means, is this right here a factor? And if it is, to continue factoring and find, completely factor this polynomial. So I want to know if this is a factor. Well, if it were, you know that that means the root would be -4, 0. And if the root is -4, 0, or if this is a point on the polynomial, that would mean that -4 would be in the box and 0 would be the resulting remainder. So basically what I'm trying to prove is if you put -4 in the box, will you get 0 as the remainder? So we need to set up our synthetic division. The first thing we want to do is always check if we have any missing exponents. So I notice I have x to the fourth, x to the third. I see here I'm missing an x squared, so I'm going to squeeze in a 0x squared, just an x, and then a constant. So now I know I'm ready to set up my synthetic division. So I'm going to put -4 in my box at the top. Then I'm going to list my coefficients in descending order. 2, 8, 0, 2, 8. And I know my remainder will be this last number at the bottom. So now I'm just going to go through those steps that we said for synthetic division. That is, bring the first number down. That's 2. And then I'm going to multiply by the number in the box. That's going to give me -8. And then add. Add straight down. 0. 0 times -4. Out here again is 0. Add straight down. 0. 0 times -4 is 0. Add straight down. 2. 2 times -4 is -8. Add straight down. 0. Okay, so what I did prove is that because this is the remainder, that -4 is the root. So that means that this is a factor. Yay. All right, so what that means is I can rewrite my polynomial in a new way. Instead of leaving it like this original big polynomial that says 2x to the fourth plus 8x to the third, blah, 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 I can write this in a new way. So my new polynomial is going to say p of x equals, I know that x plus 4 is a factor because I just factored it out. And I know my resulting polynomial has to do with these coefficients down here at the bottom. Remember, I started with x to the fourth, so now I have x to the third, x squared, x, and then just my constant. And we only need to list the ones that are relevant, so I'm going to list this as 2x to the third plus 2. I'm not going to list those zeros in between. Now, we learned some factoring things today, and we can actually continue to factor this polynomial out here at the end. We can keep this one going. So I'm going to say keep going. And you all know with this one, there's a GCF. I see here that the GCF is 2. Ooh. Sorry, technical difficulties. All right, GCF is 2. So if I take that GCF out of just that part, that's going to give me x to the third plus 1. And hopefully you recognize that this is that cubic pattern, that sum of cubes. So that's going to give me x plus 1. Right, this is the one here. I'll write it out just so we see all the different parts. This is the one that's going to give me like x times x times x, 1 times 1 times 1. All right, so that's going to give me a factor of x plus 1. And then x squared. Multiply them together and change the sign, so minus x or minus 1x if you want, and then plus 1. So now if I write the final factored form, So if we're going to write what is completely factored, complete factorization is going to be my GCF, I'll put that one in the very front, so P of X equals, GCF is 2, my original factor that I already found, X plus 4, another factor, X plus 1, and then my last factor here, X squared minus X plus 1. And there is your complete factorization of this problem using synthetic division and then also using any of our other factoring patterns. All right, so make sure you have those examples in your notes, and we will get practice, practice, practice tomorrow.